Hello everyone! Time for your video key for your optional group test, if you took this test in the year 2024 at least. So I've shown all the work already. I'm just going to explain what happened here. So on problem number 1, you have to use substitution. Now this one was set up where you know 2y is equal to 3x, and the second equation has 2y in it. So instead of writing 2y right here, you can simply write 3x. And so I rewrote this equation with a 3x instead of a 2y. And then you can combine like terms to get this. And then divide to get x equals -2. Once you know what x equals, plug it into either equation, and whichever one you like, and then find your y value. So I plugged it into the top equation because that looked easier to me, and I found y right there. If you didn't notice that you could substitute 3x for 2y, like a lot of us probably get y by itself or x by itself, that's okay too. You could do y equals 3x divided by 2, and then substitute this in for that y right there. Once you multiply by the 2, you'll get exactly this equation. Okay, now in elimination, this is where we add the two equations together and try to get a variable to eliminate. If two things aren't opposite to begin with, like they are not, like we need a 2x and a -2x, or if we have -4y here, we need positive 4y right there. So just multiply either or both equations by a number of your choice. If you do both equations, it'll be a different number to create opposite terms. So I multiplied the bottom one by 2 to create a 4y, which will cancel with this -4y. Again, there are different ways to do this problem. So you might not have done it exactly like this, but the idea would be the same. Once you create opposite terms, these cancel when you add the equations together, and you get 5x equals -10. Now solve for x. Once you know what x is, take it and plug it into either equation, whichever one looks easier. I plugged it into the top one, and you can see that work right here to get your y value. If you eliminated the x's, you probably would multiply the top equation by -2 to start, and then you can eliminate x right away and find your y value first, but that's up to you. All right, the next set of problems solve using either elimination or substitution. So the way this one's set up to me, since everything's lined up, we have x's and y's on the same side equals a number. I think that's set up nicely for elimination. You can use substitution if you want. So I multiplied the bottom equation by 3 to create this new blue equation. This is just the top equation rewritten. And now my x's cancel, and you can see the work here to get y. Once I know what y is, plug it into either equation and find your x value. And you can see that work right over here. On B, since there's already a variable by itself, like y equals something, or it could be x equals something, then it's already set up for substitution. So I took 2x minus 5 and plugged it in for that y right there, which is what you see right here. So this blue equation is the bottom equation, except instead of this y right here, I've plugged in 2x minus 5. Then distribute. Make sure when you distribute -4. So it becomes -8x plus 20. And then I combine like terms, subtract the 20 from both sides. So I did that in one step, and then find x. Once you know what x is, plug it into either equation. Since this one is already y equals, this is the easier equation to plug it into, because then you just get y directly after you plug in 2 for x, which I showed right here. Okay, on number 4, now a lot of people did this by actually solving the system and then seeing what the solution is. The real idea behind, and that's an okay way to do it, but the real idea behind this is you plug in 4 for x and you plug in 2 for y into both equations and see if it works for both. So plugging in 2 and 4, I got 2 equals 20 minus 18, which is true. Plugging it into green, I got 12 equals 4, which is false. So this is a solution to the first equation, but not the second equation, and therefore it is not a solution to the system. Okay, solving each graphically. No work to do on these problems whatsoever. People got a little bit confused when they first saw these on the group test, but you figured it out, which is good. So you're just looking for the intersection point on a problem like this. It's just right there. Find it. On this one, just use Desmos. So you could theoretically, graph by hand, but that's not how I'm having to do it. I just want you to understand that the solution to a system graphically does mean the intersection point. And make sure you're clear that these are two separate problems. This is not the graph of this system. This is number 5, separate problem altogether from number 6. All right, now in a word problem, number 7, and you're going to be able to solve this however you want. I'll let you look through the solving. I'll show you how I set up the equations, but I solved it by elimination. So once I set up my equations, I saw 35 here. So I multiplied this equation by negative 35 to create this, and you can follow that work to get to your solutions. But let's talk about where the equations come from. So there's two equations that are typical. One I call a cost equation. So in the cost equation, you know the total cost of something, $10,072. So you're going to have an equation that is equal to 10,072. The equation that is equal to 10,072 is the cost of something times how many of those things you have, plus the cost of something else times the number of how many of those things you have. So I've defined my variables right here. Make sure you define your variables. It's just saying what each thing represents, so I know that you understand what the problem is actually doing, or what's happening in the problem. So you do cost of one thing times how many plus cost of the other times how many equals total cost. Sometimes you have two equations like that. Like you might know how many hamburgers and french fries you bought that cost this amount, and then you bought a different number of hamburgers and french fries and it cost a different amount. So it's the same kind of equation, just twice. The other most typical type of equation I call a totals equation. So we know there's a total of 314 students. So if there's 314 students that go, well, this total must come from the number of students who bought a full price ticket and the number of students who bought a discounted ticket. So it's just number of one ticket plus number of the other ticket equals total number. And then you solve the system from there, which I already talked about, and you can see that go through there. All right, and then the 3 by 3. So this is where you use elimination twice. Now you might do this completely differently than me as far as what you decide to eliminate. But I took A and B, and you can see this over here. A and B I added together, so I got 4x right here. Add these together, 5y. These just cancel out, so that's why I didn't multiply either equation. They already cancel, so there's no z over here. And then 10 plus 9 is 19. Keep in mind, I have told you that when I give you a problem like this, you will get integer answers. I'm not going to give you one that has any sort of fraction or decimal. So if that happens to you, then you know you've made a mistake somewhere and go back and double check everything. All right, so we have a new equation here that has just x and y. So now we need a second equation with just x and y. So since this has, so we got to eliminate z. Since this has 3z and this is negative z, I multiplied this equation by 3 to create negative 3z. So I can add it to the bottom equation, and these z's will cancel. And you can see I added those, and I added those. A lot of times students forget to add these numbers together, so make sure you do that. Okay, now we have two new equations, D and E, the purple and the black one. I've just rewritten those right here. And now I'm going to eliminate a variable again. I chose to eliminate the y because 5 is a multiple of 15, or 15 is a multiple of 5, I guess. In any case, I can multiply this by a number and get that. Really, I want the opposite, so I chose negative 3. So this green equation is me multiplying by negative 3. You can see the result here. Add to get that. These are 0, and then add these two numbers to get negative 5. And now you can find x. Once you know x, plug it back into either of your equations that only has two variables, so either one of these, which is what I call D or E. I plugged it into the purple one, so D. So I just plugged in 1 for x right there. Find your y. Once you know x and y, plug it into any of the original that looked the easiest, and then solve from there. So I chose equation B because x plus y plus z. So x plus y plus z we don't know equals 9 because of that 9 right there. And then you just solve from there. And there you go. Okay, I'll just put this on the bonus real quick. I'm not going to go over the bonus on this video key, but you can follow the work. I used elimination by first manipulating the top equation. I added 3y to both sides. And then this is not the order we normally write it in, but since the green one was already written with 4y first, I just left it like that. And so I took the 7 over here and the 5x over here. So this one just required some manipulation first. And then, of course, the answers are a little bit strange compared to what we've been doing, but that's why it's a bonus. So let's just take a look at that work, and good luck on your test. Study and practice this test, and watch the video key over and over if it's helpful to you. See you later.